I'm really happy to have you all here, and I'm really looking forward to all the knowledge and experience that is going to get shared today. Let me first share my screen so we can have some visual aid for what we'll be talking about, and then we can get going. Okay.
Yeah, all good.
Perfect. So, enhancing engineering education with Red Pitaya. First of all, I would like to introduce my colleagues from Red Pitaya who are with us here today, Niku, Andras, and Miha. Maybe you can say a quick hello and tell the audience what you do here. Niku, you can start.
Hi, I'm Nico. I'm the product manager here at Red Pitaya. I usually do a lot of things around the office, but mostly for this meeting, my role is for technical support or product information support, things around like that.
Thanks, Niku. Next up, Miha.
Hello, my name is Miha Gyura, and I'm working as a technical specialist at Red Pitaya, basically dealing with Python, C, FPGA, and testing the OS. So in today's meeting, I'll be here to basically assist with the FPGA and basically the SCPI server if needed.
All right. Thank you, Miha. And last but not least, we have Andras.
So hello, my name is Andras. I am the editor and creator of the content on the Notion pages for the workshops. I also do some of the representations, and today I'll be showing you a brief review of one of the presentations.
All right, thank you. And with that, we can share some housekeeping information. So first of all, I would like to emphasize that this roundtable is for you, the educators. So we really encourage you to share your insights, ask questions, and make sure that you get as much value out of this as possible. We will do our best. We will share what we know. I will try to facilitate and pick up as many golden nuggets on the way. But I also hope that you will be able to help me steer the discussion in the direction that is most relevant for you. So to engage, the easiest way is to use the chat. You can raise your hand, and since there's not that many of you, you can also jump in. If I miss any of your interactions, my colleagues will let me know, so we make sure to cover everything. And there will be some time at the end for the open discussion in case you have any questions that don't fit in the particular topic. To minimize the background noise, I suggest we keep our microphones off when we're not speaking. And yeah, as you've already been informed, we are recording this roundtable so we can share the knowledge created today beyond this Teams meeting. Any questions before we proceed? I don't see any, so let's continue. And YC is just joining us. Hello, YC. We're just getting started, so you haven't missed anything important.
Okay, thank you.
Now, if we move on, I would like to introduce, of course, our speakers. I will go one by one, and then since all of them wear many hats, and I was just will just introduce them through the capacity that from which we know them. Then the floor will be yours to share some more about your work, and also invite you to tell us what is one thing you expect to take away from this meeting. So first we have Professor Prasanna Rangarajan from Southern Methodist University in Texas, where he directs the Photonics Architecture Lab, and he is the creator, along with Daniel, who is also with us today, of the Signals and Systems course from which we also adapted our teaching materials. So, Professor.
Yep. Hi, everyone. As Ziga indicated, my name is Prasanna. And so really the person who deserves all the credit for putting together the lab would be Daniel, who is also on the call. And we have additional participants from SMU. So I'm eager to learn from some of the others in terms of how Red Pitaya is being adopted in your curriculum and what this means for student engagement and student experience in general. That's it.
Okay, perfect. Thank you. And next on the list is Colin Ziskowski from UC San Diego. As director at Envision, he was a great resource and someone without which our hackathon wouldn't be possible. So, Colin.
Hi. We had really great experiences with Red Pitaya. We hosted a hackathon in January and February of this year, and it was hugely successful. We had about 60 students involved in the hackathon, and they worked on high-frequency transmission of Morse code. And yeah, it was just a really I think fabulous experience for the students and for all the judges and everyone involved. So we're actually working on a certification program right now in signal processing, for which the Red Pitaya boards will be a main feature. So yeah, looking forward to hearing what other people are doing with it.
Okay, great. Thank you. Then I would like to introduce YC Wang from DigiKey. He's the Global Academic Program Director and our trusted partner in multiple projects. One of them was the hackathon at UC San Diego that Colin just talked about. So YC, what would you like to learn today?
Thank you all very much, and thank you, Giga, for the invite to this meeting. I think I would probably have a unique perspective on having seen hackathons at various educational institutions across the country and around the world. I'm available to share what I've seen. I wouldn't call it insights, but definitely what I've seen, depending on what's touched upon during the discussion. I would definitely love to hear from everyone out there what difficulties you have, especially in regards to selecting hardware, selecting parts, and how those were overcome. So looking forward to the chat.
Okay, great. Thank you. Now we are going back to California to Norm McIntyre from UC San Diego Extended Studies, who recently taught an FPGA course.
Yes.
Hello, Norm.
And yes, and we literally redid the course around the Red Pitaya. So what happened, the previous instructor that was teaching this class could no longer teach it. This was early this year. And actually we gave the first semester of the course early this year. And as we speak, the second time we've given it has actually started. The feedback has been tremendous. The students love being able to get the Red Pitaya and just instantly put it to use. The course is divided into 9 lessons, and each of the 9 lessons basically you systematically add additional functionality to the FPGA. And the grand finale at the end is we actually use both the embedded Linux on the Red Pitaya and the FPGA and have them communicating, because a lot of the students are doing projects that are using both embedded Linux and FPGAs. So it's like a perfect match, and the feedback's been tremendous. And I'm sure this is just the beginning of a lot more very cool stuff to come.
Amazing. Thank you for the kind words. And now we will stick with the FPGA team because the next speaker is Professor Andrei Trost from University of Ljubljana, who is a professor at Laboratory for Integrated Circuit Design, and I believe one of the first adopters of Red Pitaya in academia for teaching purposes.
Thank you. Hello to everybody. I'm working with FPGAs for a long time using different FPGA development boards. And I found Red Pitaya quite usable because there are a lot of designs already there, like scope application, signal generator application. And what we do with our students is we take one of the FPGA projects from Red Pitaya and apply our logic there, which communicates with existing stuff and also with software parts. So it's very usable.
Okay, thank you very much. And now that we set the table and teased some of the things that we'll be talking about, let's go through the actual agenda. So now we're the introduction part. Next, we will cover getting started with Red Pitaya. Not so much about getting started with the product itself, but how to get started with Red Pitaya in the classroom, meaning preparing the students to start working with Red Pitaya as a development board and platform. Then we will go through some courses that are powered by Red Pitaya. You could hear already what those will be. Then we will move on to student projects, so the step beyond just learning, but also working on your own. And finally, we will have some time for open discussion and talking about how can we establish some kind of an educators community, or the main question there will be how can we provide as much value for you in the future. And after that, we will, of course, close the meeting. So getting started with Red Pitaya. First of all, to go through the main features that you probably all already heard about. It has the plug and play web interface, so you can power it on, connect it to your laptop, and you can see the web interface with all the instruments, which means also that it works with any operating system, and it can be controlled remotely as well as programmed in many different programming languages, meaning that students can use what they're already familiar with. And this is all great. However, we did notice some challenges that naturally arise when working with Red Pitaya. One of them is with networking, so making sure the board is correctly connected to your device. And here we encounter many different setups, many different operating systems, networking setups, firewalls, and things like that. And another challenge is that Red Pitaya is, after all, a very versatile and capable device. And with that versatility comes also a learning curve that is steeper than it would be with a tool like Arduino. So how did we tackle these challenges? When it comes to networking, nothing beats preparation, testing, and redundancy. So making sure that we test the setups before we start the actual workshop, and then also have multiple options for students who are working to connect to the Red Pitaya. So from having Ethernet cable directly to the laptop, to using the local network that again needs to be tested and free of any firewalls or protections that might mess up the connection. We sometimes use USB-C to Ethernet adapters, and Wi-Fi is also another possibility. And then when it comes to the learning curve and also connected to the networking, we like to give students all the resources they could possibly need. And I will show you how this looks in practice. We use Notion, which for those who are not familiar with it, is some kind of a digital notebook that enables us to really quickly put together all the relevant information for students to be able to set everything up by themselves as much as possible. And this reduces the workload on our side, and they're also able to troubleshoot on their own, giving them more confidence for working with the board. So we have, first of all, connecting the Red Pitaya web interface. Then we have some resources for preparing the development environment and some examples for setting up the SCPI communication, as well as the MATLAB and Python requirements. And what I would like to highlight here is this connection troubleshooting document that we've now prepared based on all the feedback and learnings from the workshops. Troubleshooting workflow that students can go through instead of waiting for us to approach them just to figure out that they didn't put the SD card in properly, or maybe the board is not even connected to an outlet. That's a rough introduction to what are the things that we came down to when it comes to supporting students. And now I would like to open the floor to the educators with some Red Pitaya experience to share how they approach these first steps in getting students comfortable with Red Pitaya, if there were any obstacles that you had to overcome, and any tips and tricks that you may have for the other participants.
So my students are typically they're working in the industry, and I've taught courses using Arduino, the Raspberry Pi, a number of other embedded boards, and the Red Pitaya was as easy or as quick to get up as any of those others. My students, and I guess I've taught now, I want to say 30 or 40 students on this, and this has not been an issue at all for my students. It's just, they've just gotten it up. The way I show them to get it up, actually I have set up a separate network first, just get it working locally, and they follow those steps and it all works. So I wanted to stress, although you showed there were a lot of issues that you have seen for my students, which again, they're working in industry, already familiar with a lot of this, but there were really no issues at that at all.
Yeah, I see. We've had situations where you throw 60 people in a room, some of them freshmen who never worked with something similar before, and then there are some things to resolve. But yeah, of course, it is plug and play. It's as there are some hiccups or things that that come usually with different setups that people bring to the table.
Yeah, in fact, the course just started 2 weeks ago, the next one. So it's been going for 2 weeks. And of course, first week is set that up and talk on the discussion if there's any issues. And this semester, there were not a one. So that, everything's moving very smoothly. So I wanted to stress that, since you mentioned all the issues, there are certainly cases, depending on the experience, where it just works, which for me as an instructor, that is very nice.
Yeah. Go ahead.
I would like to mention something. So because we're talking about issues, generally where the issues happen, not necessarily on the Red Pitaya side, like all the units were tested beforehand, and even without testing, everything that goes out of the factory is tested. But the issues sometimes can be because of the each person's laptop operating system, like the Windows services and such, if they have some configurations, and even the networking. In some cases, you might have some limitations on that. However, we did overcome, and we tried to adjust as fast as possible to get like the biggest issues we had. The laptops of the students did not have the Ethernet port, right? So this was an issue. So the way to treat that one, we just went out and we bought this Ethernet to USB adapters that you simply can connect to USB Type-C. So I think this is kind of the issues that we're talking here, not necessarily with the product, but because it's a complex system and there is networking attached to it and the operating system on the laptop. Yeah, sorry for the for the interruption.
Yeah, thank you, Nico. Prasanna, please.
Right. I mean, I think Nico pretty much echoed my sentiments. So the thing is, I wanted to provide a sort of complementary argument. So the students at SMU tend to be more freshmen and sophomore. So, and with USB-C, it has been a challenge, depending on the operating system, depending on, so fundamentally, we don't have the entire ecosystem in place for students to be able to get started. So you would need the teaching assistant or somebody to help them depending on their operating system, the quirks, even networking issues, right? Some of them tend to be operating behind a firewall. So you need to know enough in terms of being able to debug the problem. What I think would be helpful is going forward with these Red Pitaya boards, if you can provide these accessories that would allow you to sort of connect to USB-C or USB-A or any one of those things for that matter, it would make it that much easier. So it's just a bunch of dongles that we could potentially attach and get started. Like that would be something that would definitely be helpful.
Thank you very much for the feedback. We are making notes.
And Daniel has taught the latest iteration of the signals and systems class. I don't know if we experienced any serious networking issues this time around. So probably I'll let Daniel speak to that for a minute before we move on to the next person.
Yeah, I can just tack on that. From memory, there may have been like one with a Mac, and it's just because I personally don't know too much about Macs, so I always have to remember what I'm doing to try to get their network to go back to it. But typically, it's more or less fine nowadays.
Okay. Any other comments on the networking? But yeah, to sum up, it's these issues or hiccups are more of an exception rather than the rule, and it's something that's bound to happen when you're connecting any kind of device into the setup, and yeah, it's something that needs to be resolved according to the context. Okay. If we don't have any further comments or questions, I propose we continue with our discussion. So start the presentation again, and let's talk about courses that are powered by Red Pitaya. So as a quick introduction, what we have available already to help educators get started in adapting Red Pitaya to their curriculums are the FPGA programming materials, circuits and electronics course. This one also has really nice videos that go together with the text, so covering the theory and the practical exercises. We have some things for measurements in the electrical engineering, so getting familiar with the measurement instruments and some measuring technology exercises, which were contributed by Darmstadt University. And we also have signal processing exercises that were adapted from materials provided by SMU. So, and Professor Rangarajan. And now we'd like to go deeper into these topics. I propose we start with FPGA, and Micha again will make some introduction of how we are approaching this or how we approached it for the workshops we had at UCSD, to be specific. And then I would like to open the discussion and hear from you. So Micha, I will stop sharing the screen and you can go ahead.
Okay. Thanks, Giga. Okay. Does everybody see this? So basically, yeah, I'm just gonna talk about like the general process of how we approached the task of, let's say, basically teaching the students basically how we prepare them for the programming in the FPGA for the UCSD hackathon. So as a basis, we took Professor Trost's basic Red Pitaya FPGA project, which is basically just a compact version of the standard Red Pitaya FPGA, which you can get from our GitHub webpage. And what we really like about this is that it basically teaches the students, let's say, a very important lesson, which is connecting FPGA with the C programming languages. So how these two can be interfaced together. So how we started the basically the whole course was, first of all, we used Notion, which you can see right here, to send students the instructions on how to basically install Vivado 2020.1 and ModelSim, where Vivado was used for general FPGA programming and ModelSim was used for, let's say, simulating the program. So ideally, all the students would have these two programs pre-installed, but of course, one of the major problems was the students didn't actually do this. So at the first, let's say, workshop, we ran into issues like having everything installed, and basically some students just skip over some important parts, and this like really clogged down the basically probably the experience for students, because they want to get started but they're stuck in the setup stage. Then we introduced them to the FPGA, so the basics of how to program, basically the basics of VHDL and HDL overall. And what I would like to highlight here is that we found like a really good approach to, let's say, compare an FPGA to, let's say, a real life thing, which would be a city. And I think this really helped students to, let's say, bridge the gap between this abstract thing that the FPGA usually is, and let's say at least to get an idea of how it works. So after like the introduction, we had them guided them through basically the how they can set up this basic project in Vivado and ModelSim. So basically how to add resources, how to start a simulation, and similar things. And then once the bitstream, for example, was generated, so how can they basically establish an SSH communication from their computer to the Red Pitaya, and then copy the bitstream file over there. And finally, let's say how they can change the FPGA image on the Red Pitaya itself. And after we went through all these steps, we basically introduced it to some tasks. For example, the first one was basically a simple LED counter, which like I think students like really enjoy playing with the LEDs. So this is like a pretty good step, and they basically this showed them how they could, let's say, get started. And afterwards, we used Professor Trost's laboratory exercises to create the signal generator and signal acquisition examples, where the students basically learn how they can interface with the ADCs and DACs of Red Pitaya, which was then later on important for the actual hackathon if they decided to use the FPGA. So from my side, I think that's it. So I think I would like to invite here Professor Trost and Professor Norman McIntyre to speak if they have anything to add to this.
Okay, I think you clearly presented the basic steps. Again, what I like with Red Pitaya is that we could use a working example and add on this example some things to create a really complex system on a chip. because usually if we start with only basic gates and components, we can hardly come to something usable at the end of the semester. I'm using the project that's actually on the GitHub, but adding to this project the instructions how to, let's say, easily get things prepared for compilation. That helps students really. Of course, there are issues with the versions of synthesis tools. With the AMD Xilinx tools, this is always the issue. We have to use the same version. This is the problem with manufacturer tools. That's just something that needs to be done. So that's why we are using a bit older tools, not the newest versions. And what's also important is that communication between the components. For example, if you create your own component for generating signals, then you have several registers that you would like to set from the software side. There's one issue. I think I already talked some time ago with the people at Red Pitaya that I think it's still not really good solved. I'd like to use from the software part the applications that are already there. For example, the scope application, to see my generated signals directly, that I don't need additional Red Pitaya or additional scope there. But for that case, I need to move the my register addresses out of the address space the application is using. Okay, this can be done. And I can then connect with these registers by writing a C application. But it's not easy to use the driver that is already there for Red Pitaya. I don't know, maybe I got too deep into the details. But you have one C driver that is used with many applications. But this driver is designed for the address space for the registers of the components you designed. It's not easy to open this driver to some general application. This is maybe one issue that could be solved better in the future. Otherwise, I think the system is very usable for experiments with signal processing, with generating signal acquisition, modulation, etc.
Thank you very much for the feedback. I think maybe we will have some news pretty soon that will help with this. But anyway, I will write this down, and we will have to get back on this topic to talk a little bit more to see how we can help on this. Thank you very much.
Welcome.
And I'll add three additional comments. Number one, the students really liked the photo of San Diego as an FPGA. That was really cool, right? I mean, you see here's San Diego, and hey, it's actually an FPGA. So I thought that was very innovative. It's one of the favorite photos of the course. So that's number one. Number two, the number one support issue I, as an instructor, have seen is those versions of the Vivado. You know, in the course, I clearly say install the 2020.1 version. This is the one you should use. But I am here to tell you, students will install basically every version that's out there. I think I've had a student try to install. And it's been amazing to me. In fact, even this week, as we speak, I had this exact same question. They had installed the most recent, and as we know, when you do that, the most recent, it runs into some issues. And of course, I say, here's the one to install, clearly documented. But this is one step I have seen students, for whatever reason, even experienced, even those that are experienced, somehow miss this step. So, having that right version, because everything follows having that exact version, which brings me up to point number 3. My students have really enjoyed the Night Rider project, the stopwatch, and the frequency counter. Those are 3 projects that they have thoroughly enjoyed. And what's nice for me as an instructor, I appreciated how Red Pitaya had put all those together and made it easy for me to reference and use. So I appreciate that. Where you have highlighted there on the screen to use that version, it's very obvious to me. And, even in my course material, I say that, but I'm here to tell you.
So no, this is actually very valuable feedback. So thank you very much for it. The fact that it is in the documentation, it should be. But the important thing is that we should put it a little bit more front and center.
I think so.
Yeah. Thank you very much.
Yeah. So that's it. Those 3 things. Yeah.
So I want to echo Norm's feedback on students installing the wrong version of the software. This is not from me using Red Pitaya, but I do teach a FPGA design course with another university extension system. And I have emphasized many times over, install version X of Vivado, because that's what I've built my course around, and I'm very comfortable with that. And students will go and install whatever, or maybe sometimes it's what they have from work. They have a license for a particular version from work, and every version of the software will have slightly different placements of menu options, tools, or maybe even when AMD did the big switch from the SDK to Vitis, which is their current embedded processor development platform. It was these could be very confusing to students. So one thing is to emphasize that this is not because we're not up to speed on all the versions of Xilinx or AMD software out there, but this is the one that we have written our material around. Give them a very good reason, and you should have it front and center on your site.
That's good. That's a very good point.
Okay. Thank you, everyone, for this. Now, are there any questions from the other participants that are FPGA related, or comments? Everything is welcome. If not, I will now invite Andras to give us an overview of an exercise that we did a while ago at Technical University of Munich, if I remember correctly, which is somewhere between our circuits and electronics course and signal processing. So we will use it as a transition to then also hear more from the SMU representatives. Andras, take it away.
Thank you. So hello again, everyone. So this is, I will just share my screen.
We can see.
We've been provided by a step-down converter. And what we wanted to show the students is the use of the oscilloscope app that is built into Red Pitaya. And then we also wanted to make a custom program that they can do that acquires the data and calculates the duty cycle of the step-down converter. So yeah, how we build the site is actually that the students can, like everyone can work in their own pace. So you have like every guide here for the environment setup, connecting to the interfaces, the SCPI commands. You also have some background and theory, so they can remember if they're missing something. We also have some troubleshooting. So yeah, so if any students are faster, they can like move ahead. Yeah, and there we also have like a very deep guides here with screenshots and guides and all the explanations. Yeah, also when there are some deeper explaining needed, like there is some like this question, like we can't use the built-in BMW application because like it didn't measure the correct value, so we had to develop our own one in the C language, which is represented here. And yeah, we also have each part of the code explained. What is sampling rate? Like, if somebody is not familiar with that, yeah. So students can really work on their own or work on their own as much as they can. Yeah, this is it. Any questions?
I don't see any hands on Dash, so I guess that makes it for a successful presentation. Thanks a lot.
Thank you.
Yeah, to sum up what Andras was talking about, one of the main things we noticed in the workshops is that some students will always be faster, and then they usually can get distracted with surfing on the internet or doing whatever comes to mind. So instead of that, we offer them the option to continue working with the more advanced part of the exercise or provide some additional theory, and that way they can stay engaged with the workshop materials.
Yeah, one of the feedback I've gotten from my students is they like the way, in fact, even on the screen right now as you're sharing it, you provide the information in very bite-sized chunks. It instead of just showing here's all this stuff, you systematically show it step by step. You show a little code, you describe it, you show a little code, and the students feel that's much more approachable than just this huge, massive amount of information. They can follow it in a systematic manner, and it gives them a feeling step by step they're getting that immediate success of oh, I finished this small step, it's worked, and now I'll move on to the next one. So they've appreciated that.
Okay, thank you. That's also great feedback. So we'll keep up the bite-sized chunks.
Yeah, absolutely.
Okay. Now I would like to turn to SMU and hear a little bit more from you. What are your reflections? And know that you've had some really considerable experience with Red Pitaya. What are your highlight insights?
Maybe I'll start really briefly, and then Joe can chime in, Joe and Austin, because we're trying to see if you can adopt this with the microcontrollers class. So I'll start with the signals and systems class, where we're trying to use the Red Pitaya. So I'm just going to quickly share my screen. So hopefully, let's see. So can everyone see my screen?
Yes.
Yes.
Okay, fabulous. So really, the class is intended to augment, or rather, this is a 1 credit hour lab based on the Red Pitaya, and it's the first time students are introduced to MATLAB and Red Pitaya. And so you have to find a way to sort of strike the right amount of balance in terms of introducing concepts and not overwhelming them with syntax when it comes to programming in MATLAB or interfacing with the Red Pitaya. But the general idea is to introduce them to different ways of thinking about linear systems. So you can see that all the way on the left, you have, so again, this is just a representative example, right? So you have some sort of analog input, which could be from a microphone, it could be an audio file, and then it goes through this A to D, which is built into the Red Pitaya. And then we talk about the consequences of sampling, best practices when it comes to sampling. And then you try to mimic the equivalent of a linear time invariant system using the LTI workbench. Or you could do this in MATLAB itself. You have the impulse response of a concert hall, and you're trying to sort of predict what the output would be. And so in some sense, you're trying to replicate how a particular audio waveform would have sounded in a concert hall, for example. And then this gets routed to a speaker. And so typically the input could either be a waveform that you supply through MATLAB, or it could be something that's spoken into a microphone, or it could be something that's played using a SIGGEN that goes to the LTI workbench. And then eventually it gets played on a speaker, either on the computer speaker or some other output. You could even interpret that in MATLAB, right? So the input and the output could be MATLAB, or it could be physical hardware. But the general idea is to introduce them to different ways of thinking about signals and systems. So think about it in the time domain, think about it in the frequency domain, and think about this notion of transforms, which is where systems come into play. Right. And so, like I mentioned, this is the first time students are introduced to MATLAB and the Red Pitaya itself. So we have to find a way to strike the balance. So you don't want it to be overly complicated. And where the Red Pitaya has been particularly helpful for us is the way it used to be taught in the past is you had this array of instruments on the workbench, and it was a physical lab. So which means students had to be in the physical lab, and students have different pace when it comes to learning. So it was very difficult to find a way to cram all the required material within a 1 hour slot. So instead, what we have done now is there is a in-class component or an in-lab component or a take-home component. So within the lab, you sort of introduce them to what they need to know in terms of being able to do their own investigation when they go back home. So we give them the Red Pitaya, a bunch of additional components that makes it possible for them to execute the lab. Okay, and this was particularly helpful during the pandemic. So we adopted the use of Red Pitaya just before the pandemic started raging in the US. And so that proved to be a welcome change. And so there's actually a picture of Daniel teaching the lab. Some of the students, there were a handful of students in the lab. Many others had joined over Zoom. Some of them, one of them had dialed in from China, the other one from Saudi Arabia. So you had students from different corners of the world. And so these Zoom recordings made it really helpful. Students would participate. They had to figure out a way to sort of participate and engage. But the most important takeaway from our limited experience working with the Red Pitaya has been that students genuinely like the idea of being able to work on these labs at their own pace at home. So they get to tinker with the labs that goes beyond what they learn in class. And so that really gives them an opportunity to assimilate the material at their own pace and try and do things that go beyond what they've learned in the class. Okay, and so there's a bunch of labs that are actually provided on the Red Pitaya website. So it begins with an introduction, and then you quickly talk about how do you analyze waveforms of the Red Pitaya. We talk about mixing operations, and so we use AM and FM as a use case, and then we talk about systems as opposed to signals. And then you begin to talk the concert hall being one example. And then we talk about linear versus nonlinear systems, and then show them an example of how you could implement a system on the Red Pitaya. So this is using the LTI workbench. And we talk about distinction between finite impulse response and infinite impulse response. And so here's one example. So this is something that Daniel has put together. So there's multiple labs like this one, right? So in this particular instance, we're interested in trying to understand what the frequency response of a system would be. So we try to use the LTI workbench to implement a very specific filter. And we sort of know where the poles and zeros are. So in MATLAB, you could try to use to figure out what the frequency response would be. But then you're trying to predict exactly what the Red Pitaya would see in terms of the response. So you can probe it either using a sine wave as input, or you could also use a square wave. And essentially, you're trying to figure out what the individual response of the LTI workbench of that particular system would be to Right. So in this case, the LT, it's instead of the, I should have said that a little bit more accurately. So in this physical instance, you have an RC circuit that is a proxy for the LTI workbench. So you could do something similar purely in discrete time, at which point we end up using the app, right? But the general idea would be to try and use the tools. In this case, is the spectrum analyzer of the scope to try and understand exactly what the frequency response of the system would be and what the time domain response of the system would be to this linear system, which in this case happens to be a simple RC circuit, right? So the goal is to be able to get students to recognize that sinusoids are eigenfunctions of a linear time invariant system. So they get to see that the frequency remains unchanged. The only thing that changes is the amplitude in the phase. And that's really important because we use sinusoids as a building block for signals and systems and linear time invariant systems. So this particular lab makes it reinforces that notion and makes it abundantly clear that if it's a linear system, the frequency of the input remains unchanged. Right. And of course, there's more that you could do. I think you've already heard from some of the folks about how you could do FPGA programming, how you could do measurements and things of that nature. What I will probably mention very briefly, let me just stop sharing my screen. What I will mention briefly is one of the challenges that we've had is we've had to use two Red Pitayas, one of them to produce signals and observe the signals, and a second one in which to implement the LTI workbench. So literally what's happening is you have two Red Pitayas. One of them is trying to emulate a digital system, and one of them is purely used for measurement purposes, right? So what would be nice is if you could do both of these in a single Red Pitaya, because each student has a single Red Pitaya. So as opposed to having two students work together, it would be nice if you could basically do all of this in a single Red Pitaya, right? So it has to do with the LTI workbench app having to run independent of the other apps which involve measurement. So if there's any way in which we could combine all of these into a single app, which would make it easier for to run some of these labs, then I think that would be very, very helpful. And so I think I'll hand it over to Daniel to see if he had any additional comments.
Thank you very much for the feedback.
Just a quick correction on the bit there, Persona. So it's the DSP workbench. Yeah. So it's we used the LTI workbench and the DSP workbench together.
But we're still unable to run both of them on the same
Correct.
board, right? So
Correct,
it'd be nice if you could do everything from generating the signal to monitoring the output to emulating the behavior of a digital system. So think of the concert hall example, right? You want to be able to do the entire thing on in a single board. I mean, that would be really nice if we could do that.
Okay, so as hardware goes, would you need another analog input, like another fast analog input for this?
No, I think what might help is, so it looks like right now the two apps are running independently. So if we can find a way to fuse the two of them. So it's almost like we're trying to create our own app for this particular class that involves signals and systems. Right. So that would be very, very helpful, right? Because then as opposed to having to have two boards, all this could be done on one single board. So it becomes a single board solution where people can do, because we're able to do this in MATLAB, right? So I can load an input waveform, I can emulate a concert hall, predict what the output is played on the speaker. So you're doing all of this completely end-to-end in MATLAB. Now the question is, could you do something similar with the Red Pitaya? So that way we can start providing different inputs. So you start with a tone, move on to like a triangular waveform or a square wave, then move to an actual waveform and see how this linear time invariant system would reproduce that signal.
Yeah, this most likely can be done. And again, I will make a note and we can get back to this. So what happens when you start each application on the Red Pitaya, this image is loaded into the FPGA. So what we can do, we cannot run two applications at the same time, but we have to make an application dedicated for this purpose. So that's totally doable. Yeah.
Right.
Thank you.
I mean, right. That would be very helpful. And I think maybe just one additional comment that I'd like to make is right now with that DSP workbench, well, I forget which one it is. I'm sure Daniel will correct me. So there's, in terms of the complexity of the filter, it's fairly limited. it assumes that you have a fixed number of coefficients and a fixed number of filter taps. So it would be nice. I've heard multiple people talk about FPGAs. So it would be nice if we could find a way to implement other filters. So that way I can try to emulate the behavior of a Butterworth filter, or a discrete time equivalent of a Butterworth filter or some other filters beyond the very simplistic ones that you can realize using a minimum number of taps. Right. So that would be extremely helpful.
Okay.
I can understand how. Thank you very much. That's a very good idea. I think we had planned for a filter application in the future, but we had so many developments now and so many other urgent things that we postponed it. But thank you very much for bringing this up.
Yeah. Thank you. And now, if we don't have any comments or questions from the audience, I'm aware that we ran up against the time that we scheduled for today, but I would still, for those who have time to stick around, I would love to at least briefly touch on the student projects side of things. And again, just to give a quick introduction, we're seeing a lot of different use cases with when it comes to student projects. People do all kinds of applications with Red Pitaya, and you can check all of this out on our webpage. But what we would like to focus on today is how to get students to start working on their own projects and how to incentivize them to engage with Red Pitaya and unlock their creativity. And for that, I think a good example is the hackathon we had at UCSD, where we challenged students to implement this Morse code communication between two Red Pitayas using infrared technology. And what we noticed is that was a great way to engage them and to challenge them on multiple levels. So they had to write their own software for the signal processing. They had to prepare a graphical user interface, and they also did the additional hardware for their project. Since it was done at the Envision Makerspace, they could really display different engineering skills. And for more on that, I would like to hand it off to Colin.
As I said earlier, the hackathon was a huge success. We had students from lots of different levels, from freshmen to even a couple grad students, and everybody was really able to engage with the Red Pitayas and come away having learned, I think, a great deal. And the projects themselves were pretty varied. There were some students who really got into the FPGA aspects of the boards, and other students who just concentrated on Python. So yeah, I think having this hackathon set up in the way that it was just invaluable for the students involved. And I think it really showed that the Red Pitaya boards are incredibly versatile, and you can use them at almost any level. So yeah, that's my take on it.
Great, thanks. I see a hand up from Professor Rangarajan.
Yeah, Colin, I had a quick question. Could you give us a sense of what was the makeup in terms of, did you have students ranging from being freshmen to seniors, or was it just predominantly seniors or juniors and seniors in terms of engagement for this hackathon itself?
It was really all over the board. As I said, we even had a couple of grad students, and those were people who had a little bit of FPGA experience, but it's not something that we get a ton of. I think it's becoming more prevalent in our engineering courses, but you know, up to the point that we did the hackathon, I don't know that there were any. Well, yeah, there were a couple classes that focused on FPGA, but they didn't really, I think, delve super deeply into it as you can with the Red Pitaya boards. But even, you know, we had some freshmen and sophomores who were really able to grasp what was going on and to do a lot with it. In fact, I think the winning team from the hackathon was composed mostly of sophomores. And the team with the grad students on it, they didn't win at all. So yeah, it just shows that it can be used quite universally.
Yeah.
Thank you.
Thank you very much. Thank you very much, Colin, for the kind words. I also remember I was very surprised because in my training we used to learn basic stuff and then more and more advanced, and then the time caught on and we learned microcontrollers and a little bit of FPGAs. But then we saw some kids in San Diego. They were struggling with the soldering. So they had a little bit of soldering part for the front end to translate the infrared to electrical. And I was a little bit concerned, you know, like if they struggle with the soldering, like what is going to happen with the hackathon. And then I was amazed that the guys were really very good at programming FPGA, like the same guys. And yes, the winners were like this group in the corner that never asked any questions, you know, like nobody thought, but they had the most interesting implementation. And yeah, that was really surprising to see.
YC, I see you have your hand up.
I absolutely do. Let me lower it. So, one thing, one quick feedback that I want to provide to the Red Pitaya team, and also maybe to other professors on the call, is that having seen a lot of hackathons, especially right after COVID, a lot of the students are super enthusiastic and excited to be involved with hardware. However, the uniqueness of the Red Pitaya hackathon that I witnessed firsthand was that this is a board, I would have to say, that's on a slightly different level of difficulty from an Arduino or a Raspberry Pi that you would normally see at other hackathons. And if you make that the only option available to you as a piece of hardware to use, then students will, you know, pick it up very quickly. I've seen at too many other hackathons where, you know, because, you know, a lot of companies like to insert their own boards into the hackathon, is that if they have that initial boards checkout session at the start of a hackathon, students will usually go and grab what they're familiar with: Arduinos, Raspberry Pis. You know, even if you have an Arduino of a slightly different color or slightly different shape, they may not go for it simply because, well, they go with what they're comfortable with. And I don't blame them. They only have 48 hours, 24 to 48 hours to get something going. They want to have something they're familiar with. So what is unique about the Red Pitaya hackathon in this case is they were limited to only using the Red Pitaya. And the students actually show they are appreciative of being able to play with more advanced hardware, and there really isn't a worry about the learning curve, in my opinion. Red Pitaya did a great job training students before the event, so that it took away the learning curve that students would normally encounter if they are forced to learn something new at the start of a hackathon, which is how a lot of student hackathons are organized. It's like, okay, there will be workshops 2-3 hours before the hackathon kicks off, and that's the only learning learning time they have on any new pieces of hardware. So naturally, I don't blame them for going with Arduinos, which is what every one of them would know. So what Red Pitaya did with the training as a lead up to the hackathon was very unique. I've not seen that around before as well. I think Colin can attest to that. Students showed up in droves, simply because, well, they're interested in that new novel information, and it worked out pretty well. I'm done.
Yeah, indeed.
Okay.
Thank you very much, YC.
Yeah, thank you. And yes, go ahead.
I was hoping to add something to that. Is that okay? Can you hear me?
Mm-hmm. Yeah, we hear you.
Okay, great. Sorry, I realized I could turn on my camera too. Hey, everyone. First, thanks a lot for having this roundtable talk. It's really enjoyable. I think extending off of what Colin and YC shared a moment ago, I loved that there were those workshop buildups because, again, just bringing students that are interested in this FPGA skill, they know they want to find, many of them want to find jobs where they actually incorporate it. Maybe they've taken a class or even a couple that incorporate it, but they haven't found, many of them have not found ways to connect it to a project, to connect it to the maker studio or maker spaces that we have. I think they really enjoy these maker studio environments that, for example, Colin is a director of. And I think those spaces, having that connection with the FPGA courses is big. One reason for that is, I think a way to measure the success of that is how many of those students are putting this on their resume. I think many of them are seeking jobs in this kind of middle ground of hardware and software, and it is difficult to find these resume items where they can show off these skills outside of their classes, because I have a class that I teach that has FPGAs in it, but how can they, again, just show it off on their resume, show it off in their interviews? And I think this group of 60 students that went through this, now have that resume item and now have that connection to industry that, again, just wasn't quite there. So I'm excited to see that layout. I think this hackathon, the way that it had the workshops, for me, I hope to kind of incorporate some of that into my class as well. So, that could kind of lead into bringing them into the maker space, bringing this skill into their projects. I guess I'm looking forward to more of that. But again, thanks for sharing all this. I think there's a lot of good energy in this hackathon spirit with FPGA. So thanks again.
Thank you very much for the feedback. I think we should advertise this actually a little bit more. Like the students don't think about what they can use and what they cannot use on the resume, but we should kind of put this idea out there, because definitely it will be helpful. Especially when we see in the industry, even in NASA, the Red Pitaya boards are used for discovering new types of radars or so many other interesting projects out there.
Yeah, exactly. Yeah, thank you also from my side. And now I see that people are already having to sign off this meeting. Thank you for your patience and, of course, for all your engagement and insights today. It was really great to hear the enthusiasm and all your experience. So I hope that also you found it valuable. It was very insightful for us, definitely. Now, before we let you go, as promised, we will send you the recording of this conversation so you can watch back if you missed anything or if you would like to dive deeper into something. And we will also share with you that circuits and electronics cheat sheet along with the Notion pages that you saw today, so you can have a closer look at that. And yeah, I think this is all from my side. Sure, go ahead, Nico.
Yeah, so I was going to say this as the last thing. Thank you one more time for all the good feedback. I have here like 7 post-it notes. So that's really valuable for us. Sometimes we are working on this closed environment, and it's really hard to put ourselves in the shoes of the student or in the shoes of the instructors, right? So if you have an idea about how we can improve our product, like software or hardware wise, or even like I don't know, to make a special kit, any help that would anything that would be helpful to increase the adoption in the academic, we are really open to it, and we would be really happy to receive this feedback from you. So my email is always open, but really any address on the Red Pitaya will be discussed in our meeting, so you cannot miss us. Thank you very much.
Yeah, thanks a lot. Expect the materials in your inboxes, and we will also probably send a short feedback form where you can tell us what you would like to discuss on the next roundtable, since I see that there's already interest for that, and that we could easily talk for at least another hour. So yeah, have a great day, everyone. It was a pleasure to spend time with you, and see you next time.
Thanks, everyone. Bye-bye.
Bye.
Thank you very much for your time.
Goodbye.